Good morning, kids. I'm Sridhar sir, physics teacher. Today we are going to discuss about the toppling. It's a very small and very important topic. So let's start with this one. Let's assume that a car is moving on a road, with a road. When it is moving straight along the road, the weight mg is acting on it. Then when it is taking turn, this is when it is taking turn. When it's taking turn, when the car it is taking turn, it will start tipping above one of the side. So here the normal contact will act, and there's a weight mg are acting here. There's a weight mg. Then further, so finally, what will happen at one position? What will happen? It completely fall off. Like this, it will fall off. This particular process, this is called like everything as like a toppling. And that particular thing is what we are discussing. So now you can say like, okay, what is this? This particular portion is it's not a toppling. It is moving car. This is about to topple, and this particular thing now it topples. This phenomena is basically called as a toppling. We'll discuss this application for various forces. Okay, various situations we are going to analyze it. Now we have the next situation. There's a block kept on the some surface. The weight mg will act here. Then I'll apply a force on it. I'll apply some force. Okay, let that force be F here. Then the action of this force, the same blocker, here the same force F is applied. The weight mg is acting, and it is about to tip off. Means as I start pulling this particular block by force F applied at one end, here at this point, the block automatically starts rotating. And at this particular point, you can say that it's completely topples. It starts rotating. So the idea, so what you can write is like the toppling, you can call toppling, or it hits about NP. So there's a P. So when you start applying this force F, okay, the normal reaction will gradually shift. And about point P, it starts tipping, or about point P, it starts rotating like this. This particular thing is called as a toppling. Okay, now we have to give a basic reason, like how do the toppling occurs. All that analysis is what we'll be doing that. Now, here I taken a block. When I don't apply any force, basically what happens is through the center of gravity or the center of mass, the weight mg will act. And the normal reaction by the ground, okay, this particular thing is ground, will pass through the center of mass. Okay, there's a normal reaction. This will be acting. And what is the state of this? This will say at rest or equilibrium. So there's a basically a center of mass, the weight will act. Here the normal reaction by the ground on the block. By the block on the ground will act in the direction. This will be no use for us. Now let me apply a force for this. Then we'll see that what conditions will arise here. This is without any application of force. These are the forces that are acting. When you apply force, then we'll see what conditions will arise here. Okay, now I'm applying some force F on the top of the block. We'll assume some dimensions. Let H be the height of the block. Let length be the L be the length of this one. Let L be, these are the dimensions we are assuming. So we are assuming a block of this kind of B, L, this H. So we are assuming some rectangular block whose height is height, length L, and this is a breadth B. The weight mg will act through the center of mass. As I start applying this force F, the normal reaction earlier which was acting here, now it starts shifting up. So it will start acting at the on the right side of the center of mass. So here this particular thing, the normal reaction will act like this and will start shifting it. Next question comes, what makes the normal reaction to shift? So we'll start with this one. Suppose say like let the normal reaction be at the initial point only. So why you are shifting normal reaction? Let the normal reaction, let it act. Let the normal reaction act here only. So we'll discuss about the torque about the center of mass only. So how the torque due to center of mass will be? This will be R bar, this F bar. The torque due to the applied force will be clockwise. Then this particular block will start rotating about the center of mass due to applied force. But we know that it is not rotating. What is the state of the block? The block is not rotating, rest or equilibrium. But due to the like a torque due to applied force, so you can see this is R bar. This net torque will be clockwise. So then what should happen to the block? The block should rotate. But as such, we know that it's not rotating. So I'll write here, block at rest and not rotating. I think there's some issue, no? So we are claiming that net torque is non-zero about center of mass and not rotating. So what actually practically happens is the normal reaction, what we assume that will pass through center of mass, in fact, will not pass through center of mass. Then where do it lie? It will shift like this. It will act somewhere here. So let this be X here. There's a normal reaction. The normal reaction starts shifting, will start moving away from the center of mass and it will act in this particular direction. Now we'll see that how the net torque about center of mass is zero. So from the net torque about center of mass, why it should be zero? Because the block is rest, no? Block is at rest. And not rotating. So for that purpose, so what is the torque by the applied force? So this will be the perpendicular distance. So how much will get this as h by 2? Let me write, indicate here. This distance will be h by 2. So now torque due to applied force will be F into h by 2. This will be clockwise. You can see here now. This R bar, this F bar. So the net torque will be clockwise by the applied force. Then torque due to the normal reaction. Torque due to the normal reaction about the center of mass. This is R bar and this is N. So the torque, this will be anti-clockwise. Then that everything we are showing in terms of perpendicular distance. What is the perpendicular distance? Perpendicular distance, this will be the perpendicular distance. And the N bar is acting like this. So this will be like a X bar. Everyone okay? You are able to understand? No. So torque due to normal reaction will be N into X anti-clockwise. So this will be F into H by 2. Clockwise, let it be take negative. Anti-clockwise, let it be positive. You can see clearly now the block. Why though we applied a force F, why it will not rotate? Why it will not rotate? The reason for this is like because of the net torque about center of mass is 0. That's why what it is not rotating. Okay, so then you applied force F, then why it is not moving? Okay, then we'll bring the idea of the friction. If it is kept on the, if like a rough ground usually will be rough. No? If there will be a friction acting. Then I say block is at rest. Some static friction will act. Then torque due to the static friction also, how it will act? It will act in the F into this distance will be h by 2. So this also will be clock. So here, try to see this one. The torque due to friction, this R bar, this F bar. So how the torque due to friction also, this also will be clockwise. Then how much it is equal to? It is equal to F into h by 2, this distance. This is the friction, this is the perpendicular distance from the axis, like F into h by 2. This will be torque due to friction. This torque due to applied force. This is a torque due to normal contact will be anti-clockwise. Okay, I did this. So this will be our right feature. This torque due to friction. This is a torque due to applied force. This particular thing is torque due to normal contact. Okay, what is basic conclusion? The normal reaction can shift. Here, the normal reaction basically till now what we analyzed is like it will act opposite to the mg, but the basically normal reaction what can shift depending on the requirement. Why it will shift here? Because the net torque about center of mass will be zero due to applied force and the friction. This will set up clockwise. The torque due to friction also clockwise. Torque due to normal reaction will be anti-clockwise. So for that purpose, the normal reaction will not act here. In fact, will shift. So will shift here. So it starts shifting like this. So this is the one basic idea. Now we have to discuss like for what maximum value of F the block will topple, all this basic condition. So one what is a very important point we are going to conclude. Note the normal reaction can shift. There's one very important thing which we'll be uh, using in our all discussion. Can shift. The requirement is there. That's why it is able to shift here. Here, the net force, net torque is zero. Okay, the normal way, the net torque about center of mass due to weight mg is zero. That's why torque due to m is also zero. So here it will not shift in this case. Here it is shifting. It's all about this shifting of normal reaction is what we'll be using in almost all the problems. Okay, fine. Okay, now we'll find out the minimum force, find the minimum force needed to topple the block. Let me assume like this will be like a height h. And let this be width b. The weight mg will act here. Then I applied a force F. I want this minimum value of this. Then it is kept on the rough surface. I'll keep on increase this applied force. I'll keep on increase this. Then we know that there'll be a friction also will be acting. And the friction will act in this direction. And what is the state of block? Block is at rest. Block will not be moving. Block will be at rest only. The block will be at rest only. Then what are other forces acting? The normal contact force will act here, and let this be the shift. I'm using word very often, the word shift, this particular thing. The normal reaction actually should act here, what till now we learned here. But here the circumstance, the situation is such that as you apply this, as you increase this applied force, the normal reaction will shift, will act here, will act here. Now, for a certain particular value of force F, the normal reaction is acting at a distance x. Agree this. Okay, let's discuss the net torque about C. Net torque about center of mass should be zero. Net torque about center of mass must be zero. Then we'll unlike the torque. Torque due to the applied force. This will be h by 2 and this is f. And how is the torque? Torque will be clockwise. So this should be f into h by 2 clockwise. Torque due to the friction force. This will be h by 2, this length, total h by 2. And here the friction force is acting. Then the torque here will be r bar cross f. So it will be in this direction. So this should be f into h by 2. This also will be clockwise. Means the torque due to applied force will be clockwise. Torque due to friction also will be clockwise. We'll check the torque due to normal reaction. This is x bar. This is the normal reaction. Produced like this. This length is x. This is a normal reaction. Then how the torque will be like a x bar cross n. X bar cross n. So it should be equal to n into x anti-clockwise. Now, what is the maximum permitted value of this shifter? It cannot be more than b by 2, no? Because this length is how much? This length will be b by 2. What is the maximum permitted length of x? The maximum permitted length of x will be b by 2. So as I keep on increase this applied force, the friction will increase. This will be a static friction. Okay, fine. This will be static friction. The friction will keep on increase. As you increase the applied force, the friction force will increase. Proportionally, the x also will increase. Proportionally, the x also increase. What is the maximum permitted value of x is what we are going to check it. The maximum permitted value of x is equal to b by 2. The next condition is like, as we increase this applied force, the n will shift. Okay, we'll take the next condition. It's like we were discussing now, we have to calculate this minimum value of force for which the block will not topple, or maximum force for which block will topple. Both are same. So the applied force F we applied, the force F is applied, then the weight mg will act, and here there's a friction, and this is rough surface, the same rough ground or rough surface. Then as I keep on increase this applied force, the normal reaction will shift. Earlier will act here, now will act here, will act here. Finally, there's a maximum displacement the normal reaction can have. So what is the maximum permitted displacement of normal reaction equal to b by 2? So therefore here now the normal reaction will pass through this edge here. So we'll call this as a point P. Then what is the shift now? The shift is b by 2. Agreed. So now what we have to calculate? We have to calculate this particular value of force F. Then we'll apply the torque about point P. The net torque about point P should be 0. The net torque about point P should, and it's about to topple. In that case, F into this length is H2, F into H clockwise. So, like, what is this particular torque? Here, about point P, we are discussing the torque due to applied force will be like this, because this is the perpendicular distance and this is F bar. So the torque will be R cross F or H cross F, and angle between H and F 90 degree. So we'll get FH will be the torque that will be clockwise. Then torque due to normal reaction. Torque due to normal reaction will intersect axis of rotation. About point P, the block is about to tilt or about to rotate. So the normal reaction will intersect axis of rotation. This one. So torque due to normal reaction will be 0. Then torque due to friction. The friction also will intersect axis of rotation. So torque due to friction also will be 0 about point P. Now, who all will set up torque? Torque due to only applied force, that will be clockwise. It will be clockwise. Torque due to weight, it will be anti-clockwise. I'll show it clearly. Torque due to applied force, like this. Torque due to weight, it will be in this sense. Now this will become plus mg into b by 2. So this will write minus fh plus mg b by 2. Then f equal to mg b by 2h. Okay, this is a basic the force. Then what we should call this one? Minimum force for the block to topple, or the maximum force for block not to topple. Both are same here. Because see, I'll apply force here. I'll apply force. I'll apply force. Then what is the maximum force for which it will not topple? Or minimum force for which it will topple? Both are same. Maximum force for which block will not topple, or minimum force for which block will topple. So it depends on what all? It depends upon this dimension. So that H and B is what finally it matters. Here I think small h, capital H I took it. And the idea will be same. The height, the height and the width of the block. This will become height. This will become width here. So these things will matter. So let me. Everyone, okay? This I think maximum force for which block will not topple, or minimum force for which block will topple. So we'll discuss further some ideas. Now, so I'm bringing two situations. You can see the rectangular block. Here the rectangular block, the width is B, we are taking, the height is H1. Next, another little bit long rectangular block, the height is H2, the width is B2. Let mass be the same. Mg will act here, Mg will act here. Then let me apply forces. I'll calculate the particular minimum value of force F which is needed to topple the block. Then when you apply that particular minimum force, it is kept on rough surface, so the friction will be acting here. Here also the friction acting, and we applied a force. Here also friction will be acting. Then About point P, it is going to topple. Here P2, you call P1. About this point, we'll discuss the torque. The torque due to applied force will be like this. Torque due to mg will be in this direction. Unless I can show like this is the torque due to the applied force F1. So what is the height H1? This will be H1 and this is F1. So the torque here will be clockwise. No? Then torque due to this will be, and let me write it here. Torque due to applied force about point P1 should be 0. So F1 into H1 clockwise. Mg into B1 Y2 anti-clockwise. Here this one. H1 into F1 clockwise. Mg into B1, this Mg will be anti-clockwise about this point. Then we'll solve for minus this is the force required. So definitely you can see here which is greater, H1 is greater than B1. What's that like? Yes, okay. B1 greater than H1. Now in this case, torque due to the second diagram. I'm asking you to look at here, second diagram. Now the torque due to applied force about point P2 will be clockwise. Torque due to the weight will be anti-clockwise. Okay, fine. Then the normal reaction will be acting here. Here also the normal reaction will be acting here. So when you apply that minimum force, which is required to topple, the normal reaction will be acting at this edge, at this corner. Now we are going for this minimum force. We'll write down the equation. Torque due to all the forces acting about point P2 should be 0. What are the forces acting? The normal reaction. N2. Here this N1. So the net torque should be due to applied force F2 into H2 clockwise. Mg into B2 by 2 anti-clockwise 0. What about the torque due to the friction? Will be 0. It will intersect axis of rotation. Torque due to the normal contact, it will also intersect axis of rotation. Torque due to mg into this distance B2. When you apply that minimum force, the normal reaction will be acting at this edge or at this particular corner. Then we'll simplify this. F2H2 plus mg B2 by 2 equal to 0. F2 equal to mg B2 by 2H2. Now here H2 less than B2. So what do we expect here now? F2, you compare these two. You compare these two. Then F2 what happened will be less than F1. Means will be easy to topple. So like what actually happens when you apply force, and I'll show it a little bit. So when you apply that force, it will topple like this. It will fall off. It will tip about point P. It will tip like this. When you pull this, when you pull with the force at this particular point, it will topple. It's about to topple above this point. So which case the block will easily topple here, this one. In this case, the block will topple very easily than this one. So here we have to apply the larger force. You can see B1. Here in this case, you have to apply the smaller force. So So this will easily topple compared to the this block 2 will write it. Which block will topple easily? The block 2, provided if you apply a force which is equal to greater than or equal to this one. If you apply force which is greater than or equal to this, the block 2 will topple. If you apply force which is greater than or equal to this, the block 1 will topple. But altogether, the force needed to topple the block 1 is more than that of the block 2. The reason you can check it from the geometry here. Like this, we are analyzing the basics of the toppling here. Now we'll analyze what is the conditions for the block to topple before sliding. So when we apply this particular force, the two situations less. First, the block will topple before sliding, or it may slide before topple. So which particular phenomena? Sliding is something like a moving. Toppling is something rotating about this particular corner. So which will apply force. So what conditions? Like first it will slide, then topples, or it will first like a topple, then it will slide. So that particular thing is what we'll be analyzing here. So now minimum force for the block 2 already I discussed. Once again I'll derive it. So here I'll apply a force F here. Then the friction force will act through this point. Then the normal reaction will act through this point. Then the torque due to the applied force and the torque due to the mg, and this length will be b by 2. Then the minimum force already we derived it. It was equal to how much? Minimum force for block to topple. That should be equal to F into H about point P, mg into b by 2. Solving this, we'll get F equal to. So there's a minimum force. Then minimum force for block to slide. This should be equal to, F should be equal to, the minimum force for the block to slide is F should be greater than or equal to mu s mg. Here we'll write this as greater than or equal for toppling. So there's a least force. Anything force greater than this, it will topple. It will rotate about point P. Then what about the sliding? When you apply this force, if the block starts sliding, the center of mass will undergo displacement. So what is the minimum force I should apply? Mu s mg. Anything greater than or equal to mu s mg, the block will slide. Then, okay, next condition is for the block to topple before sliding. Condition for block to topple before sliding. This force. So what should be the block topple before sliding? So this force should be less than this one. This force should be less than this. Then only what will happen? The toppling will take place. First toppling should occur. First toppling should occur means this particular force. This particular force should be less than this one. So here we'll write it here. mgb by 2h should be less than or equal to mu s mg. So if you're getting confusion, actually we'll apply a single force. There's a maximum force, or say better you say a limiting friction, better say. Now we applied a force. When the minimum force for the block to slide, that should be equal to limiting friction. Then we applied a force such that it is greater than this minimum force for toppling, but less than limiting friction. I'll write it here. This will be, I think, I'll put, let me put it in the form of equation. So the minimum force for the block to topple should be less than limiting friction. What is the minimum force? Minimum force should be mgb by 2h. Should be equal to mu s mg. So this will become b by 2h. So what is the condition now? Mu s greater than b by 2h. If this condition is satisfied, then the block will topple before sliding. Is it okay? No, this particular thing, like it. Condition for the block to topple before sliding means mu s should be greater than mu mg. What is the mu s? The quotient of friction here between the block and the surface. Like this is what we are defining things here. I'll take it. Similarly, for the block, condition for the block to slide before toppling, mu s should be less than b by 2h. Conditions for block to slide before toppling. Mu s should be less than. So in this particular situation, you apply a force on the block, and if mu s less than b by 2h, first block slides, then topple occurs. If mu s greater than b by 2h, if mu s greater than b by 2h, the block will topple before moving. If mu s less than b by 2h, you apply this force F, then what happened to the block? The block will first slide, then toppling. So these are the two important ideas. So then either the force will determine or the physical conditions. The physical conditions will determine whether block will first slide, then topple, or block will first topple, then slides. So it all depends upon the quotient of friction between the block and the ground and the dimensions of the block. Like a dimensions, like this will be the I think I'm showing everything in one picture. Huh? So whether the block will first slide or topple, whether block will first topple or first slide, so will determine the quotient of friction mu s, this one, mu s here, the height and the width of the block. These things what we are showing it. And this is some data, try to remember, very, very important for you. Now we'll keep a toppling of a triangular block. Here we have a triangular block. The weight mg will act through the centroid. It is kept on the rough surface. What the minimum force that should be applied on the edge of the triangular block so that it will topple. So here, what are the dimensions? Dimensions, let it be base b by 2. The height of the triangle, let it be h. I'll apply the force F at the tip of the triangle, at the topmost point here. Then what is the minimum force I should or minimum horizontal force I should apply so that it will topple? Then when I apply this force F, the friction will act. So there's a direction of friction. Then the weight mg will act through the centroid. Then the normal reaction when you apply that minimum force, the normal reaction will pass through this particular point P. So we applied a force F, and this force F is minimum. The weight mg will act. Then the frictional force, as the block is at rest, so the static friction will balance this applied force. As we apply that minimum force so that the block is about to topple, the normal reaction will initially when applied force is zero, this one zero, then the normal reaction will pass through the center of mass. As we increase this force, F, the normal reaction will shift. Then when it is you applied force is minimum, the normal reaction will be passing through this edge or the corner. And there's a permitted, the normal reaction cannot act here over the maximum possible shift of the normal reaction equal to B by 2. We will define the net torque about point P. Applied force F into H clockwise. About this point, the torque about this point. The torque about this point. Torque due to weight M. About this point, torque due to applied force. Like this will be R bar. This is a bar. The net torque will be clockwise. Torque due to the normal reaction that will intersect axis of rotation. Torque due to the friction, it will also intersect axis of rotation. So torque due to normal reaction and friction will be zero. So wall will set up torque, the applied force, and this mg. So what is the torque due to mg? Mg into this B by 2. Fh, this will be clockwise, mg into B by 2. Then this would be equal to F equal to mg B by 2h. This is a minimum force. If you apply force greater than this, this triangular block will tip about point P. So we can bring this for various objects and not only just rectangular square block. For various objects, we can bring this toppling concept. Now we'll discuss the toppling of an hexagon. I applied a force F here. So we have considered hexagon of side length A and mass M. So the weight mg will act through its centroid or the center of mass. Then it's kept on rough surface. So here a friction F will act. And the applied force is such that it is less than the limiting friction. So the block will be at rest. Then as I increase this applied force, initially when this applied force is not there, the normal reaction will pass through the center of gravity. Then as I increase this applied force, the normal reaction will shift, will act here, then, and finally there's a maximum displacement. No? The normal reaction cannot act here. The normal reaction, we cannot show it here. The normal reaction cannot act here. So the maximum possible displacement of normal reaction should be equal to A by 2. So about what point, if you apply force on the hexagon at this particular corner, it will tip about this point. It will tip about this point. It will tip about this point. So now we'll go for the torque due to applied force like this. Torque due to the gravity in this direction. And what about the normal reaction? The normal reaction will act through this particular point. And then we'll write down the net torque. Net torque about 0.0 due to applied force. What is this total height? We have to calculate this total height. F into H clockwise. Torque due to the weight. Torque due to weight will be this mg into this A by 2. what is h? How to calculate h? I think the h can be calculated from here. So this is hexagon. No? This angle will be 60 degrees. This side length is a. This angle will be 60 degrees. This angle will be 60 degrees. Then this will be a sine 60 degrees. This will be a sine 60 degrees. I'm applying the concept of sine 60 degrees equal to opposite by hypotenuse. Similarly, sine 60 degrees here equal to opposite by hypotenuse. So I'll get a sine 60, a sine 60. So the value of h should be equal to 2a sine 60 degrees plus mg into a by 2. This anti-clockwise, I'll take negative. Anti-clockwise, let it be positive. Then minus 2a root 3 by 2 mg 2 root 3. So if you apply force less than this, it will not topple about point P. If apply force greater than this, it will tip about point P. So here we are learning the toppling for the various shaped objects. This is a basic idea. Okay, kids. So this is about the the introduction for the toppling what we have studied here. In the coming classes, we will explore the higher level problems related to this toppling. Okay, thank you all of you. All the best. Do well and try to analyze concepts, think and work out more number of problems, think on more number of problems. Okay, we'll meet in the next video with the application problems on the toppling. Okay, bye all of you. Thank you for watching my channel.